Dual nature MCQ from NEST 2021, first shift, question 6 from the PDF. In a photoelectric setup, electrons of maximum kinetic energy 0.5 electron volts and 1.3 electron volts are liberated when ultraviolet light of wavelengths 310 nanometers and 250 nanometers respectively are employed. Then the calculated value of the Planck's constant is closest to. Observe that all four options are in SI units, with the power of 10 being negative 34, and only the numbers are different. Here it is 4.5, 7.5, 5.5 and 6.5. Okay. Now the equation that we have, which contains the expression for maximum kinetic energy, is our Einstein's photoelectric equation, which says K max equals h nu minus phi naught. Correct? K max is equal to h nu minus phi naught, where symbols have their usual meanings. Correct? Now we have got two values for the maximum kinetic energy, right? We have got two values for the maximum kinetic energy, and we have also got two corresponding values of wavelengths. Okay, we have also got the corresponding values of wavelengths. Now we know that if we consider this to be y equal to mx plus c, then what is the slope? Slope is equal to Planck's constant. Okay, so basically that is what they want us to find, right? So, value of the Planck's constant using the data. And we also have a ready-made formula for that, which is y2 minus y1 upon x2 minus x1. Correct? Simple formula that we'll study in straight lines. What is y2 minus y1 in this case? In this case, y2 minus y1 will be k max 2 minus k max 1. And what is x2 minus x1? It is nu 2 minus nu 1. Okay, now what is k max 2? K max 2 is 1.3 electron volts. K max 1 is 0.5 electron volts. And remember, because the options are in SI units, we need to multiply these by 1.6 into 10 raised to negative 19, so that the energy will be now in joules divided by frequency. Now we do not know the frequencies. Instead, what we know is are wavelengths, right? So how are we going to calculate frequencies from wavelengths? We know the formula. Speed of light is equal to nu lambda, right? Speed of light is equal to frequency into wavelength. So what will be nu? It will be c by lambda. Okay, so put that c here. C is 3 into 10 raised to 8 into bracket. What is the wavelength corresponding to 1.3 electron volts? 250 nanometers. We need to take its reciprocal. Okay, 1 upon 250 into 10 raised to negative 9 minus 1 upon 310. Okay, now remember that 10 raised to negative 9, which is for that nanometer part, that is in the denominator of this, right? Here it is 10 raised to negative 9 in 250 and 310s, well, in that term. So when you write it here in the numerator of the denominator, that will become 10 raised to 9. Okay, hope you understood that. Now what we need to do is we just need to calculate the stuff and look for the correct, I would say, number. Okay, rather the number that is to the left of the decimal point. Okay, fine. So let's now do the calculation. 1.3 minus 0.5 is 0.8, right? So that will be 0.8 into 1.6. Let us write down the powers of 10 separately. Okay, so this is 3 here, 3 here, 10 raised to negative. Okay, now look, this is 8 and 9, so that is 17. So this is right away minus 17. Now here it is 310 minus 250. Okay, 310 minus 250, which is 60. Okay, which is 60. And then in the numerator now we must take 310 into 250. Raise your hands if you understood what I did. 310 minus 250, that is 60, and 250 into 310, that will go in the numerator. Okay, fine. Now this one 0 and this 0, we can cancel that, we can cancel each other. Okay, so effectively what we have now is a 25. Okay, 25 into 310. So let me write it as 31, and let me give 0 to 16 into 0.8 upon 3 into 6 into 10 raised to negative 36. Now look, we can now use calculator. Okay, we can now use calculator because, well, it's a non-scientific calculator that can do the job for us. Okay, just mere multiplication and division. So let's do it and get the value. Okay, it's 25 into 31 into 16 into 0.8 upon 18. That's 551.1 bar. Okay, that's 551.1 bar. So we've got the answer now, that the answer is C because it is 5.5, but let us just check whether our powers of 10 match. Okay, now when I shift this decimal place to its left by 2 units, 2 places, sorry, 2 places. Okay, basically I'm making that number smaller, which means I must increase the power by 2. So that is indeed what we have for Planck's constant. So the correct option is C. Okay, understood?
Yes, sir.
Yes. Now look, if you mark D because that is closest to the actual value, then you will lose marks actually, because this is a negative marking question. So don't do that. Okay, and they are not dumb to set up the problem and give option D there. Maybe, who knows, in option B they may give 6.626 into 10 raised to negative 34, which is, let's say, closer to the actual value, actual accepted value. Don't do that. You're supposed to calculate it using the data. That's why they have used the word calculated. That means they don't want the value that you know. They want you to calculate the value, and that value happens to be option C. Okay, that value happens to be option C.